Welcome, everyone. Today is June 11th, and we have a very, very exciting community meeting today. We have a guest presentation. Ori Steele will be talking about Skit and some opportunities for collaboration, so very excited for that. We'll start off with a quick project round robin, and then we'll dive right into that presentation. William, I'll throw it over to you first if you want to give some updates for the client work.
Sure, sounds good. Yeah, so I just wanted to do two brief updates. One is that as of last month, we released the 3.x series for Sigstore Python. This is a pretty huge release in terms of new API and CLI services added. We added Dizzy support for both signing and verification, for example. And so with that came a lot of changes, which means if you happen to be a Sigstore Python user, we would love to see you upgrade and report either any bugs or usability issues you have. So far, we haven't seen a ton of uptake, so we don't want to end up in a situation where people are stuck on the order series. And then related to that, GitHub Action Sigstore Python will also upgrade to Sigstore Python 3.x pretty soon. And I'll cut a new major release when that happens.
Awesome. And for another release, Frederick or Meredith, did you want to mention the 0.4 release?
Sure. For Sigstore Go, we have added a lot of support for signing, mostly done by Zach. So we do now support signing with country signatures from Recor and TSA.
Very, very excited to have this release. If you've been following along, we've had verification added for a bit. This adds signing, and we also have bumped this from unstable to beta. As Zach will mention, GitHub has been using this for a bit, so we feel confident in the correctness of the code. There may be some minor API changes before a 1.0 release, but look forward to a 1.0 release in hopefully the coming months. Are there any other client updates? All right, for infrastructure, I believe last week we mentioned a upcoming maintenance window. This has been postponed just due to timing, so we'll give an update when that maintenance window is rescheduled. Probably assume about a month or so out. Was there anything else you wanted to add there? Perfect. On to the docs. I believe, Bob, did you write this?
I did. Some late breaking news because it just ended 30 minutes ago, but the OpenSSF TAC meeting today, Sigstore was granted $50,000 to make some improvements in its documentation, which was a request that we took forward to the TAC to provide more consistency across the various language definitions, as well as to reflect some use cases that weren't currently covered in the docs. So super excited that that was approved and look forward to getting that work started here in the next few months.
That's really fantastic to hear. I'm really excited to see that work come through. It should be very nice to add some more details to around some of the automated signing and verification workflows that we encourage within Sigstore. So very excited to see that. All right, are there any other project updates? Cool. So I'll mention just for outreach and events real quick. We mentioned this previously, but there is Cloud Native Security Con in Seattle at the end of the month. I know at least one Sigstore talk will be given by Bob as well as Luke from the TSC. So if you're there, come say hi. I think it'll be great. All righty. Ori, I'll hand it over to you.
Awesome. Thanks for having us here. And I'm going to try and screen share a slide deck, which will
Let me know if I need to stop sharing.
Hopefully you just see a Microsoft PowerPoint slide, and if I hit present, does it remain an acceptable size for you all? Excellent.
It's me.
Awesome. So I'm Ori Steele. I'm CTO and co-founder of a small Austin-based technology company. And for some context, my background's in cybersecurity. I got a cybersecurity degree back in 2012 or 13, and I've been working in the sort of digital identity and certificate space ever since. And I spend a lot of time on digital identity standards, digital certificate technology, and I come at this sort of area from a physical supply chain security perspective. And one of the sort of really exciting things has been seeing the interplay between security technology the physical supply chain community has adopted, and security technology the software supply chain, the digital supply chain communities have adopted, and the sort of the cross coordination, cross pollination between those two initiatives is something I'm always really excited about. And I've been following Sigstore for quite some time, and I'm deeply passionate about many of the building blocks that Sigstore is based on. And so today's presentation is going to cover some parts of where did those building blocks come from, and how can Sigstore be used to support other folks who are interested in leveraging those building blocks. And I'm here with Hank Burkholz, who has worked with myself, and there's a number of other folks on the call here who are active contributors to the IETF SCIT working group. And you feel free to interject as I go through this presentation. Anyone, you're welcome to just come off mute, ask questions. Love for it to be interactive. And at the end, we can get to questions, and don't be afraid to ask the tough questions. I love challenging questions, and I hope this presentation is valuable. So just for a review of the agenda, I'm going to talk about transparency services a bit more in the abstract. I think you're all, as Sigstore contributors, very familiar with the idea of a transparency service in the concept of software supply chain. But this is a sort of industry terminology that's spanning a larger area of software products today. And I'm just going to kind of position transparency services in the broader ecosystem. And then we'll look at the specific transparency work within the IETF, the common primitives that IETF standards are sort of developed to support. And we can talk about how those primitives are used in Sigstore today, and how you can use Sigstore to create some of the newer primitives that are being developed within the IETF. And the last bullet point is really about where can there be interoperability? Where can you use Sigstore in the IETF ecosystem? And where might Sigstore use IETF building blocks in future updates to the open source ecosystem? And I saw the question on the slides. I can definitely make the slides available after the session. I'll coordinate offline on that. I think that's all I wanted to say here. So in a lot of ways, the whole transparency ecosystem was sort of launched by the initial certificate transparency work. So there've been Merkle tree-based verifiable data structures and log-based systems for some time, but certificate transparency was the first time that the technology was really sort of implemented by a number of large vendors, and providing this value of allowing you to monitor the certificates issued for a given domain in a log. And that enabled a kind of transparency that was really valuable, but it came along with a lot of challenges because of the scale of the way that certificates are issued and the ecosystem that certificates exist in. I'm not gonna go into the full details on certificate transparency, but I will say that there are two RFCs within the IETF, 6962 and 9162, I think, which is the newer version. And most folks have only implemented 6962 and didn't implement the newer version. And one thing I was going to say on the previous slide is a lot of open source developers may have had very limited exposure to the standards ecosystem, like standards developed within the IETF or within W3C. And open source and open standards are actually significantly sort of different. They're different areas of work and collaboration. So as you see these RFC numbers, I would like for you to think about their purpose is to enable interoperability. Their purpose is not to create a specific product. So in open source, or in closed source software products, we're trying to build a product to solve a problem for customers. But in standards, we're trying to describe the minimum interoperability that enables products to coordinate and communicate in a shared language. And so they're not Sigstore, the project, and the open source software that it comprises, and the IETF standards are in very different spaces, and they fit together very nicely. I hope I'll convince you of that by the end of the presentation. So one area of transparency work, which is really exciting to keep an eye on, especially for Sigstore users, is this concept of key transparency. There was some initial work from Google on key transparency in the early days, and there's been recent announcements from Apple and for others around transparency services for end-to-end encrypted messaging. And the concept is sort of similar to certificate transparency, but there's some unique challenges for ComSec providers. Like the primary property that you're looking for with key transparency is to make sure that your ComSec provider, like WhatsApp or Signal or some other end-to-end encrypted messaging system, is not serving a different public key to encrypt messages to different parties in that ecosystem, because that could enable interception of those messages and decryption of the confidential communication. That's sort of similar to the problem of wanting to make sure that there are not multiple certificates issued for a given domain. And it's sort of similar to the concept of, for a software package, making sure you understand who's signing that software package at what time, et cetera. So the concept of transparency generalizes to securing artifacts, but also to transparency regarding authentication material for supply chain actors. So you're all experts on software transparency. You're here participating in the Sigstore project because you understand it's important to secure a software supply chain, and you see value in using digital signatures and authenticating issuers of digital signatures. Those are the parties that sign, that produce the signature, and associating those public keys, certificates, and signatures to software supply chain artifacts as they're produced over time, and storing that information in an immutable log in some system where you can look up to see historic evidence of this hash for this binary signed by this party at this time. And then later, when you discover that there's a potential problem with that binary, you can identify that binary exists in other systems, et cetera. So there's obviously Sigstore, which you're all familiar with, but there's also the SigSum project. And I wonder, is anyone here familiar with SigSum? Are you following that work? Do you have?
Yeah, I think we've engaged with them a little bit.
Cool. Yeah, they're. I think they have a separate Slack channel. There's like 1 million Slack channels now. But I found the SigSum project to be really interesting, comparing what parts of Trillion and the Merkle tree system they are interested in versus what parts of that system Sigstore is interested in, and comparing that also to the parts of that Merkle system that IETF is interested in. So the overlap between each of these communities is all of us care about Merkle trees and transparency logs, which are built from a Merkle tree. We all have sort of different ideas about what goes into the Merkle tree, and some of us have different ideas about how you construct the Merkle tree. But the idea of a transparency log built from a Merkle tree is very much a sort of shared primitive across each of these software components. And that's exactly the kind of thing we look for when we're considering, is there value in standardizing? Because if there is a shared primitive that all of these projects are using, and it's just not documented, in a way that protects it from slowly degrading over time as one implementation makes changes to it, there can be a value in standardizing. In this case, each of these projects is compatible with the RFC 6962 Certificate Transparency RFC, the first one. Might have gotten the RFC number wrong. So I think of that Merkle tree as being the kind of binding agent between many of the transparency initiatives we see folks working on today. Although I'll note, like, the key transparency work within IETF is looking at an alternative Merkle tree structure with the some more privacy sort of oriented features. And as a general comment, transparency logs can be built from Merkle trees or from other systems. And so depending on the properties that you're looking for, you might wish for a very simple Merkle tree, a very complex Merkle tree with a prefix tree overlaid, or some other system that you would like to manage your transparency log. And the IETF view of like those transparency logs is that you should be able to make those choices for different use cases. But with Sigstore, and Sigsum, as I understand it today, both of them are looking at just the RFC 9162 Merkle tree with SHA-256 today. Yep, please just interrupt.
I wanted to just ask, have you been following the C2SP work that Filippo has been driving, who's also been working on Sigsum as well?
C2SP or C2PA?
C2SP, so this is, I'll post a link here. This is a community spec project that he's been working on, which includes some specification work around constructions of logs.
Yeah. So I've seen this, and also there's been a lot of alignment and collaboration on the tile structure. Like, I think Trillian just recently has added support for tiles, and the Sigsum project was really interested in working on tiles as well. So and there are interesting sort of choices at the leaf layer of the tree. Like, Sigsum has a very opinionated idea of what goes into the leaves, and Sigstore also has a very opinionated way of like what goes into the leaves. Santiago, please.
So I think all of the slides are really a pitch that I think everybody kind of like subscribes to. And in a way, it gave me a little bit of a deja vu, because I think we've been trying to make something like this happening. What I'm really curious to know is your perspective on two things. One of them is, why do you think it hasn't happened yet? And two, what do you think would be the best approach to actually make this collaboration a little bit more?
What's the it in that sentence? Like, is it like everyone using the same transparency log format, or everyone sitting in the same room? Like,
no, the it was, my understanding is that the thing that we all want to walk away out of these meetings is we have standardized a portion or the whole of Sigstore, Sigsum, and Friends in corresponding RFCs with appropriate splicing. That is what I think it's the outcomes. At some point in the future, there's RFC XXXX and a collection of those that give us what we want. My question is more, even though we all agree that that's the outcome we want, I don't see, or I feel that the reason why we haven't progressed too much in that direction is because we don't have a roadmap or rules of engagement or strategies to actually make that happen.
okay, yeah. So I hope this is the
Actually,
beginning of,
wait, can I take it?
yeah.
Development of standards is a multi-year effort. The fact that Skit and Sigstore are making such fast progress should not belie the fact that most of these standards takes multiple years. The question of whether we standardize Merkle tree formats has kind of been pushed out of the skip case, where we're saying, hey, we need the functionality, and here's how to represent a receipt, and allow the industry and implementations to try either tiles or different mechanisms to get there. I wouldn't wrap the two of them around and say, hey, why we aren't already there. Trying to get consensus and the minimum viable requirements does take time and it takes work. And that's why we work in some of these groups.
Yeah, I would also add that, like, there's a right time to standardize, and it's usually when you have a large amount of adoption where the small differences in implementation are starting to have a real significant negative impact on the community. So it could be that a software project can't grow. If people want to use it, but because it's not a standard, it can't grow anymore. It can't continue to serve its purpose. Or multiple vendors are using it, and they're using it in a slightly different way. And every time they have to communicate, it's expensive or broken in some way. And that could be another, like, motivating factor for when it might be time to standardize a piece. But the process of standardizing is also, like, you can publish a standard that's sort of like a monolithic framework that covers an entire use case, or you can cover individual pieces of that framework where you have to kind of integrate them and add them all up to get support for that functionality. A great example of that would be like OAuth, which is not one document. It's like many, many, many documents. And you have to read all of them to understand how to do OAuth in a specific flavor, for example, like OpenID Connect or
I don't mean to, like, interrupt, but I'm aware of all of this. I do follow ITF mailing lists. I participate every now and then on, like, the GPG, like RFC 4880. I'm aware that this is like a slow, sort of like a process that it requires continuous sort of like a effort, that sometimes you want to, like, splice things in multiple standards, combine them all. I think this is useful for everybody to have context. But my question is more on the sort of like the specifics of our circumstances. We have like two open source communities. As far as I understand, Sigstore, at least when I engaged with them, they were mostly open source developers from a particular corner of IRC that I chatted with them for hours about things back when Sigstore was like up and coming. Sigstore is a Linux Foundation project. How do we all get into the table? Yeah.
I hope the next slides will cover this better, because, like, at the minimum right now, there is a standard building block we're all relying on, and it's the SHA-256 binary and Merkle tree that was defined for certificate transparency. So we all share that one standard building block right now if you use that system for your transparency log. But there are other pieces beyond just that Merkle tree. So this is the beginning of the interoperability opportunity section, and the first interoperability piece is the SHA-256 binary Merkle tree that's constructed in the RFC, 6962 and 9162, and that RFC covers a way to produce a particular Merkle root with a specific algorithm, and you can implement compatible and faster versions of that algorithm in many different open source projects. So, there's Trillion, it's open source. You can see exactly how Trillion computes a Merkle root from a series of input messages. But there could be a different implementation that is faster, or maybe it's slower and it trades off compute for storage, like the tile implementations we see that are starting to emerge. But regardless of how you represent that tree, the important part for interoperability is, like, you're all producing the same kind of tree for the same input set of messages. You get the same Merkle root, and then you can swap one Merkle tree implementation for another in your software stack. And that's how you really got good interoperabilities. If you can do that, then you can do direct substitution for that layer. But for this SHA-256 binary Merkle tree, there are sort of two, maybe three pieces that are really important to consider standardizing. So like the tiles piece is about distributing the log. I think this is a prime candidate for standardization. It's been added to Trillion. Sigsum uses it. Sigstore is maybe going to start using it because of it being in Trillion. A lot of folks would benefit from a really efficient solution to distributing these transparency logs. And documenting the tile approach in a single document, everyone could reference that document. We could easily understand, hey, you support tiles as described in RFC XXX, and you support the SHA-256 binary Merkle tree as described in this other RFC. When you use Sigstore, you get both of these RFCs because it's built into Sigstore. When you use Sigsum, you get both of these RFCs because it's built into Sigsum. But maybe some other product would only use one of them. Like maybe it doesn't use tiles, or maybe uses tiles but with a different Merkle tree algorithm, for example. And another piece is like what goes into the actual logs itself. So, and you'll have to forgive me for not being the Sigstore expert here, so I hope you can all correct me, but my understanding is that Sigstore logs, Trillion logs, store various different types of like original document. So there's a question of like, what's the content type that your log supports? Does your log support entries that are only one content type? The Sigsum, as I understand it, is focused on just the hashes of Go packages. Like it's not about storing arbitrary content, but I could be wrong about Sigsum. I'm not an expert on Sigsum. Sigstore has a series of types, like a type manifest structure. Maybe Hayden, just jump in. Let me interrupt.
Yeah, I can chime in a little. For Sigsum, I believe there's some similarity into what we're storing in Sigstore, roughly that it's a tuple of an artifact hash, a signature, and what I usually call as a verifier. For Sigsum, it's just a public key. For Sigstore, this could be a public key, or this could be a certificate to support the ephemeral signing key flow that we support. So roughly within Recore, we support many different types. Those are more client optimization so that clients don't need to know how to parse certain structures. And instead we can push all that logic server side to know how to extract the artifact hash, the signature, and the verifier. Like a jar is a good example of this, that you could upload a jar and we know how to parse it and extract this metadata. But roughly I summarize it as the tuple of those three things. And for what it's worth too, we're thinking a little bit about what a V2 API might look like, and kind of circling around, more narrowly focusing on these, like the hashed Recore D structure, which is again the hash and signature and verifier.
Yeah, so it sounds like you've got, roughly speaking, you have a content type for the content that's going into the log. You have the verification material, which is a public key or certificate, and they have the signature over the content. And by putting all of that in the log, you can prove this key signed this content at this time, and all of that is immutable because all of that is what goes into the Merkle leaf. So the purpose of the numbers here, like 1, 2, 3, 4, and I borrowed this beautiful tree diagram from some place close to Sigstore, either Transparency Dev, Sigsum, or Sigstore. I can't remember where the tree is from, but it's a beautiful tree. And you can imagine a scenario where each of the entries in the leaf is a different kind of signed content. Like maybe a certificate is a signed public key. So maybe 1 is just a certificate. Maybe 2 is a signature with PGP. Maybe 3 is a signature with HOSI, which is the technology we use to secure OAuth tokens. Maybe 3 is COSI, which is a signature format that's used to secure digital mobile driver's licenses today. 4 could be a Dizzy signature. So you can have all of these different ways of signing in the bottom of the tree. Or you could have a transparency log that says, when you store information, you are only storing, in this log, you can only store Dizzy signatures, for example. In this log, you can only store PGP signatures. So there's flexibility in what a service provider will allow in their log. And Sigstore has a set of policies that codify that say, like, these are the kinds of data structures that can be stored in the Sigstore log. Skit does not have opinionation like that beyond saying you can only use cozy. So my friend Mike Jones, who's one of the creators of JSON Web Tokens, and he's been working in IETF for years, he likes to say that standards are about making choices. Sigstore, Skit made this choice to use cozy to represent signatures. And with that came a bunch of trade-offs. Like, we can't use JSON Web Tokens to secure data and store them in a Skit transparency service. We can only use cozy signatures to do that. But because of that choice, if you're implementing interoperability with a Skit RFC, you know that you only need to support one signing format. You don't, as a verifier, need to think about verifying each of these independent signing formats. And obviously, there are a lot of signing formats out there. There's Dizzy, there's Cozy, Hosey, PGP, CMS. And tomorrow there will be 5 new ways to sign something, I'm sure of it. So this is a place where I highlight the cozy piece, not to say like, oh, Skit is so smart, like Skit decided to only allow cozy signatures, and Sigstore lets you sign things in so many different ways. It's to show that, like, when you're producing a signature in Sigstore, you have support for cozy already. It's one of the signing formats. It's in this record blob for the version 001 entry. And in the future, this version 2 or whatever could be compatible with Skit. Like, it's just, here's the content type. Here's how you include a cozy signed document in a Sigstore log. So that's like one place where I think there's interoperability potential. And then I think the other place to consider it is like these receipts, which are a signature over the Merkle root with the inclusion proof for a piece of content. The receipt structure, like the Merkle proof part of it, is shared. So Sigsum uses the same inclusion proof as Sigstore, which is using also the same inclusion proof as a Skit transparency service that uses that same transparency log. So regardless of which solution you picked, you would still have the same authentication material to prove inclusion of a leaf in a Merkle root. So that's another place where there could be an opportunity to align. I think the inclusion proof and consistency proof piece is already covered by the RFC that describes the Merkle tree. Like, that's where those data structures come from today. But how you package them and distribute them, Skit is defining a way to package them and distribute them with cozy. In the future, you might decide you are going to package and distribute them in a special way for Sigstore that's unique to Sigstore. You could use cozy, and then you'd be directly compatible, or you could give the option to use cozy when someone wants it, and use Dizzy when someone wants it, or that kind of thing. So I'm kind of like showing you the puzzle pieces the way I see you could choose to fit them together. I'm not trying to make a recommendation to you all. I'm trying to just explain, like, where are these building blocks in each of them and how might you connect them. There's one other point I would want to make on this slide, which is, and I don't fully understand the way that you distribute your trust root information, but it is, as I understand it, sort of a collection of certificates and a Dizzy signature around sort of some metadata. Is that correct? The way that the Sigstore trust roots are distributed today? It's like a bundle. I think you call it like a Sigstore bundle.
Yeah, just to confirm, are you talking about individual signing events or the root key material that we distribute?
The root key material, like to trust a given transparency log. Like if I'm running a version of Sigstore on-prem somewhere else and I want to distribute the root material for that log.
So yeah, we're using something called the update framework, which roughly the way it works is there's just a signature over metadata with some mechanisms for preventing things like rollback attacks or freeze attacks on the metadata. And ultimately, the root of trust for all of Sigstore is the offline keys that are held by a number of community members across academia and companies. If a
That's for the public instance, right?
Correct. And for any sort of private deployments, you have different options. You could deploy your own tough repository, of course, if you wanted to. One of the other things that we standardized recently is a trust bundle format. This is what we distribute within Tough, which defines, originally it was just a set of files, and then we came up with our own metadata scheme for associating those files with specific log instances. One of the concerns here was if we want to rotate a log or rotate a CA, we want to still consider it valid, but only during a certain validity window. Yeah. That's why we needed this scheme. So we have this repo protobuf specs, which defines our specifications in the protobuf format. You'll see JSON mostly used, but this is what we would recommend to somebody if they didn't want to deploy a Tough Tough repository, but still have this format.
The signature in that bundle, that's a Dizzy signature today. It's like only a Dizzy signature, I think, right?
So no, this is one reason I was just wanted to check on this. So the other place you'll see bundles used is for individual signing events, where you can sign either with a Dizzy signature or just a raw signature. So that's the other place you'll see bundle used, which is a little bit overloaded.
Cool. So like in both of those places, like just as a general terminology thing, like there's raw, as you said, raw digital signatures, which is like you implement the crypto. You have a public, it's an interface that satisfies the keygen sign and verify abstract interface, right? Like that's what it is, digital signature is. And then you have concrete envelope formats, which take that sort of abstract digital signature interface and they add some envelope metadata around it. And they could add a lot of complex envelope metadata. They can do JSON and base64 URL encoding, and that's what JWT and Hosey do. In Cozy, it's CBOR and CBOR structures. And Dizzy, it's whatever Dizzy defines to be able to do that. So we call those like envelope structures because they're not just a digital signature, they're a way to communicate metadata about the digital signature, a place to put the digital signature. They can potentially indicate whether it's a detached or attached signature, that kind of information. And with Skit, it's all based on Cozy. So any place where you see a digital signature in Sigstore today, if that digital signature is of an envelope format, like Dizzy or Cozy, that's a place where if you wanted to, you could decide you're going to enable a Skit alignment option, where you could say, in this layer, I would like for a Cozy sign 1 format of the bundle, or in this layer, I would like for a Cozy sign 1 entry type, like protobuf entry type. Like, at least that's my kind of high level understanding of like where these potential pieces could fit together. So I basically have covered all of this already. We're all sharing the raw digital signature formats. In some cases, we're sharing envelope formats as well, like Cozy, which is building on a raw digital signature format and a serialization like JSON, or like CBOR for Cozy, JSON and base64 for Hosey. In Sigstore, there are also some of these higher level protocols that are used to secure end users. So like you use OpenID Connect, and then you have ephemeral certificates, which are built, connected to the access token you get from the OP, right? Like high level, that's kind of how Sigstore is managing identity. So you're relying on a family of standards for a digital identity assurance, and you're relying on a family of standards for the certificate assurance piece, like the RFCs that define extended key use and all of those other great details of certificates. And so like some of these building blocks are, they're at IETF, they're published immutable RFCs. Some of them are being updated. So there's drafts that, happening at IETF that you might take advantage of as they become more mature and they become RFCs, or you might go to IETF and complain about the draft and say, like, we really shouldn't do this. It's going to be super bad for the ecosystem. Like, please stop, abandon this draft. That's a totally fine thing to do in the IETF, to say something's a bad idea. And the media types, like, I think we're talking a bit about briefly C2PA at the beginning. There's a lot of different manifest formats that are being developed in the just software supply chain ecosystem. And then there's different versions of manifests in physical supply chain or other industry domains. I think of the manifest file formats as being basically special kinds of media types that the industry's agreed they're going to care about. So there's a family of them for containers that are being developed by container experts. And when you get a specific JSON structure that has to have these fields, and the fields have to be a certain length or contain a specific value, or there's a maximum document size, like once you start constraining your JSON data model, your XML data model, your CBOR data model, you eventually want to give a name to that instances of that data that are constrained in that way. And that's what media types are for. So saying something's application JSON is like less useful than saying it's a specific type of OCI or Helm chart in JSON format. Okay, I think I've covered this already, but the interoperability points are basically where signatures are produced and where you recognize a public key or certificate. That's the way that I see it. So in Skit, it's cozy signatures, but you can use a certificate or you can use a regular public key. And in Sigstore, it's OpenID and ephemeral certificates or longer lived certificates for the key material side. And then there are some use of Dizzy with public keys. And there are other signature formats that you can support in Sigstore, which I'm less familiar with, which is like on the GPG side, like meeting people where they are today. A lot of people are still signing software with PGP. I'm not familiar with the details around how Sigstore supports those scenarios, but like as a general rule for transparency systems, you want a representation of verification material, some understanding of why you should trust that verification material for an identity. And you could use OpenID for that, or you can use some other trust ecosystem for that layer. And then you need a signature format that you can verify that with that key material. And you need to put all of that in a log. Like, as you said before initially, like that's the common primitive that all these transparency services are doing. And so for some set of choices that are supported with in Skit, Sigstore can be a service provider for those combinations. In other sets of choices, it might not be compatible with all of what is defined in Skit, but there's parts that still could end up being compatible. So like if Skit defined a manifest format to distribute trust roots for a cozy-based transparency service, like maybe that wouldn't be compatible with Dizzy. But if Sigstore supported both Dizzy and cozy, then maybe it is compatible with the choice of using a specific signature format to distribute that trust material. Differences. I basically covered all of this. The slides will be available, and I'm in the Sigstore Slack, so you're welcome to ask me questions anytime. I'm in Sigstore Slack. I'm in the Transparency Dev Slack, in the IETF Slack. Happy to answer any questions you might have. I know these are like text-heavy, standards-heavy slides, so if you're digesting this information later and you have questions, I'm happy to answer them. Roy, go ahead.
There was one thing that you didn't cover off here, Ori, which is if the trust is in the counter signature and it is regular X509 certificate chain, attesting to the Sigstore signature itself, then the standard evaluation of the counter signature will proxy as I don't need to know anything about the Sigstore specifics about the identity. And it gives you a bridge, and it doesn't break out of the standard RFC mechanisms of evaluating certificates, which is an interesting property of using the counter signatures, which is, hey, even if they expire, you can go back and get a receipt, a newer receipt, and solve the problem or change the algorithm. And that interesting stepping stone between the two worlds is something that wasn't covered here.
Yeah, so I I should have covered it on this slide, where you see like 1, 2, 3, 4. Like you can imagine, each of these are signed in a different, unique way, and it's challenging for a verifier to verify all of those different ways that a signature can be produced, because you have to understand how to parse the key, how to parse the envelope, how to verify the signature, etc. But if your signatures on the Merkle root are all with X509 or all with cozy, then you can basically just verify the inclusion proof, and you can ignore all of that agility at the envelope layer and the base of the tree. And that is a really valuable property of transparency logs. Like first of all, you trust the transparency log maintainer to not maintain multiple copies of logs and sort of be weird, different inclusion proofs, right? So there is a trust role that exists, and there's ways to detect violations in that space. But the transparency log can also decide, I'll take PGP, JWT, CWT, X509 signatures, but I'll only hand you back Dizzy. Like, that's a choice the transparency service provider could make. And it gives a verifier a single integration point on verifying receipts. And that can be really valuable. And then, you can also have multiple logs. So you could have a log that only hands back Dizzy signatures for inclusion proofs, and one that only hands back cozy signatures for inclusion proofs. And you could have multiple receipts for the same signed artifact. And if the verifier can support one of them, you can still have transparency even with each individual transparency log only supporting one signed inclusion proof. And the term signed inclusion proof is like what Skit's referring to as a receipt. Please ask questions.
Quick question. Could you define countersignature in this context?
Yeah. So countersignature is a formal term. There's a RFC for it. And it's in the RFC for countersignature, it's about a signature over another signature. And cozy countersignatures are a way to take a cozy sign one and then sign it again. So I don't use the word countersignature because I don't want to confuse countersignatures from the cozy RFC with Skit receipts. But if you think about what signing a Merkle root for an inclusion proof for a cozy sign one is, it's a kind of countersignature with extra steps. You're not signing just one signature. You're signing every entry in the log that produced that root. Every time you sign that root, you're effectively producing a kind of countersignature for every entry in the log.
Okay, that makes sense. So I guess just to kind of align on terminology, we are using terms defined by Trillian. So we'll refer to that as a checkpoint, which is a signed Merkle root. I'll also mention that we have been exploring more the integration of witnesses, which also some of this work is called out in the C2 SP work. You'll see this in SIGSUM as well, which in itself also define a countersignature specification, which then is a witness that has countersigned a checkpoint, effectively verifying consistency, which is how you mitigate these things like split view attacks if multiple logs are run. I don't believe I've seen anything mentioned about this in Skit. I don't think this is something that's a hard blocker, or
so there is the Skit has a potential dependency on a draft in the IETF cozy working group, which represents how to describe a cozy receipt. And cozy, that draft is called cozy receipts now. It used to be called signed Merkle tree roots in cozy or something like that. The reason it's called cozy receipts is that the data structure, the envelope data structure that enables that receipt structure for an inclusion proof or a consistency proof, it can work with things that aren't just simple Merkle trees. So we wouldn't want to say, oh, it's always a signed Merkle tree root, because that would limit the kind of receipts to only receipts that depend on a signed Merkle tree root. But certainly receipts do work with signed Merkle tree roots. And you can produce them with a cozy and CBOR serialization envelope wrapped around them, or you can produce them as raw signatures like the C2 SP specification does. And, I think if you're ever producing like a Dizzy signature over a Merkle root, you're also producing a kind of receipt, in quotes, same kind of deal.
I am concerned about the reuse of and redefining of terms. You know, we have the same problem with RATs and a bunch of the other things of what's an attestation, what's a claim, right? And the more proliferation, it'd be nice if we can standardize on some of the terminology.
I'm basically giving up with that. Every time a new security working group comes up, they reinvent a new meaning of the word attestation. I think the important part is like when you use terms, if you have implementers that are coming from a background, like disambiguate for them, because they're going to recognize that term and they will think it has the meaning that they're familiar with. So I come from the OAuth and like OpenID Connect and identity space. And so anytime you see the word like token, I'm thinking JSON Web Token and Cozy Token. But like sometimes you need to be more specific, and it's never too late to create a Java style name where it's like a million prefixes in front for your variable. Sometimes more verbose is clearer. Okay, so I think that's basically it for the slides. We've had some great interactive questions. I'm happy to take more questions, or I don't know how much time I have left, or if I've already gone over. Looks like I'm about to be over. I don't know how much time you allocated for this, Hayden, but thank you for having me and allowing me to present. And like I said, I'll be in the Sigstore Slack. You can always ask me questions there. I'm around by email, and I'll make sure to get you a copy of the slides as they were presented. Do you mind if I just put that in a channel in the Sigstore Slack as a PDF? Like, which channel should I drop that in?
Yeah, you can throw it in general. The only issue with Slack is it'll be deleted after, I believe, 90 days. If you have a link to it, I'll add it to the YouTube video when I go upload this recording as well.
Yeah, Hank, this is your personal SharePoint, so I don't know if you want links to this going around. I'd probably prefer to just give you a PDF drop for it. And if we could
I stood out a PDF for this. This is not a problem, and we can redistribute it. No issue. And I'm sorry that I'm on the road, but there was an accident in front of the NIST campus, and we are pretty late with everything today. Sorry.
Well, again, Ori, thank you so much for giving this presentation. This was great. I loved seeing the engagement from everyone and the many, many great questions. If you have any more questions, like Ori said, swing by on Slack. Feel free to ask. And as I mentioned, I'll upload this recording to YouTube shortly, so you can take a look.
Thanks for having me. See you all in Slack. Bye. Oh, Santiago, you have a question?
I was trying to send a thumbs up and I clicked the wrong button. Don't worry.
Cool.
Just to clarify, which YouTube channel?
I believe it's Project Sigstore.
Thanks.
All right. Thanks, everybody. Have a good one.
Thanks. Bye all.